we're going to discuss the relationship between pressure and volume. Now, this is one of the ideal gas laws right here, Boyle's law. He says that pressure is inversely proportional to volume. This means, this is just a complex way of saying that P equals 1 over V. So if something is inversely proportional, just like how it says it's inversely proportional because these things are inverses of each other, I think that's pretty obvious. But for you stupid people out there, this is what it means. Right here. Okay, so now we're going to explain Boyle's law a little bit more. So if you want to put this on if you want to put this on an XY graph, sorry, I drew it wrong.
Also, something to note is Boyle's law pretty much saying that the more pressure you have, the less volume because there's less space.
Exactly. And we'll show this by showing you this. This would be, this would be volume, this would be pressure. So this is saying as pressure goes up, volume goes down. As pressure goes up, volume goes down. Volume is going down, therefore pressure is going up. Boyle's law also gave us a formula. He said that P1 times V1 equals P2 times V2. Now, my buddy Jordan over here is going to give you some problems that you can use this formula for. So Jordan, take it away.
So practice problem number 1. It says the volume of a gas at 99.0 kPa, which is the unit for pressure, is 300.0 milliliters. If the pressure is increased to 188 kPa, what will be the new volume? So first we want to see what our P1, V1, and P2, V2 is. So just like for molarity, P1 equals, V1 equals, P2 equals, V2 equals. So we know it says the volume of gas is 99.0 kPa, so 99.0 kPa is 300.0 milliliters. So 300.0 milliliters would be for our V1. And then it says what if the pressure is increased to 188, what will the new volume be? So 188 kPa, and then we don't know that, so it's just a question mark. So first what we're going to want to do is, we're going to want to simplify before we plug in. So P1 V1 equals P2 V2. We want to isolate the V2, so divide by the V2. And then you get V2 equals P1 V1 over P2. So now we can plug in. So we get V2 equals, and then our P1, as we said, was 99.0, so 99.0. I forgot to label kPa times our V1, which we said was 300.0. So 300.0 milliliters. I don't know if you can see that. But then over P2, which was 188 kPa. Once you do this out, you get V2 equals 29,700 over 188. And once you do that, you get V2 equals 157.978, and there's more. But if you were to simplify to the 3 sig figs, you get 158 equals V2. And that would be your answer.
The temperature is staying at a constant rate. It's not going higher, it's not going lower. Question problem number 2. Now, you have the pressure of a sample of helium in a 100-liter container is 0.988 atmospheres. Atmospheres is also what you can, it's also a unit for pressure. What is the new pressure if the sample is placed in a 2.0-liter container? Now, see, that's a very good question. But first, just like for any problem, we're going to write out our formulas. Write out our variables. So you have P1, V1, and then you have P2 and V2. Again, this is all at a constant temperature. Now, the pressure of a sample of helium in a 1 liter container is 0.988 atmospheres. So you have a 1 liter container, that's the volume, 1.00 liters, and then the pressure, it says, is 0.988 atmospheres. 0.988 atmospheres. Okay, now, next part. What is the new pressure if the sample is placed in a 2.00 liter container? So it's asking for the new pressure, so pressure we don't know, in a 2.00 liter container. So now we know we have to find the second pressure over here. So we go to this formula. Now we want to isolate the pressure number 2, so we divide by the volume, second volume, take it to the other side. So once we plug that in, it will be 0.988 multiplied by 1 liter divided by the second volume. 2.0 liters. Okay, and you're solving for question number 2. So resuming from where we were, you first have to cancel out your units. So ATM is the only one that stays. So for sure, your answer is going to have atmospheres. So you can put that down. Now you're going to have to do 0.988 times 1, that gives you 0.988. And then divide that by 2, and you get 0.494. And that's your answer, including sig fig.
In this experiment, we'll be twisting it, which would put, we'd make the volume in half, and then you'll see what happens. So first I'm going to take the water bottle, I'm going to twist it, which makes the volume less, and as you can see, when I try pushing on it, it's harder, so it doesn't indent anymore. The pressure is obviously increased. So what I'm going to do is, I'm going to hold it twisted, and as I release the cap, it'll shoot out because there's so much pressure that was built up from the decrease in volume. So, and that was the air coming out of the water, which is the result of the pressure. And here's our second experiment.
Alright, so for our next experiment, we have a paper bag, whatever you want to call it, like a little bag over here, and we put air inside it, and then we trap the air by closing the bag. So now the more I push, the more pressure there is, and then it pops. That's showing that the lower the volume, the higher the pressure, so the pressure became so big that the bag actually exploded.